Now we are moving into resistor arranged in series and in parallel. If it's your first time, you're welcome. Please don't forget to subscribe and hit the notification bell to get our other videos. Now, if you look at this, what we want to talk about here is the formula we have as a resistor. Now, what is the need of knowing the formula in series and in parallel? Is because, for instance, if this I should form it in a complete circuit over here, you find out that you may be asked to find maybe the voltage in this circuit, or you may be asked to find the current. Now, when you find the voltage and current, you must use a resistor. And when you're using the resistor, you're not going to use just a single resistor, just like this 1, 2, 3. No, you need to find the total resistor. Find the total resistor. You must know the formula for total resistor, maybe in parallel or in a series, depending on the arrangement of the resistor you have in that particular circuit question you are given. So because of that, we are going to start with resistor arranged in series. Now, when resistors are arranged in series, we find out that the same current pass through them. And because of the same current pass through them, we have that the sum of the total resistance, the sum of the resistance is going to give us the total resistance. So if there are 3 resistors, I'm going to add them together in this form, and then I'll have my total resistance, that is R total. And this is also till infinity. That means how many resistance you have in series, you add them together, you get the total resistance. But if we move over to this other one, we found out that the current that passed through this resistance is different from the current that passed through here, and also different from the current that passed through here. And as so, the voltage that is here and here and here are the same thing. So now, what do we need to note? We are going to try to look at the formula for current. While we are doing that, we are driving the formula for total resistance arranged in parallel. So now we have that the current total on this particular parallel resistance is the first current plus the second current plus the third current. All right. Now, according to our knowledge of Ohm's law, we know that the voltage, which is the same here, is equal to the current multiplied by the resistance. Now, if you want to make current sort of formula, you divide by R on the both sides. You find out that I, which is the current, is equal to V over R. Now, like I told you that we are going to try to look at the current total while we are actually driving the what? Formula for total resistance. So we are going to replace the value of current, which is V over R, in this expression that we have here. So we have that but I is equal to V over R. So we continue by saying that the I total now will now become V over R total. Now notice why I did not put V total, because all the voltage here are the same thing, and this is very much equals to the first current, which I'm going to represent as V over R1. Why I use resistor 1? Because they are different with resistor, but here they are the same voltage. So I can't put first voltage, but all the voltage are the same. Plus this other current, which is what? V over R2. You already know why I put R2 plus V over R3. And this is also till the what? How many currents you have, how many resistors you have, I mean to say. All right, to infinity, but here we just have 3. Now, if we continue further, we are going to multiply each of this particular expression by, we have to multiply every of this expression by 1 over V. That is the inverse of what? The voltage. If we multiply it in this both side, we're going to have V over RT multiplied by 1 over V equals to V over R1 multiplied by 1 over V plus V over R2 multiplied by 1 over V plus V over R3 multiplied by 1 over V. Now, closely look at this. This will cancel this because the voltage are the same thing, and this will cancel this, and this will cancel this. So from here we have 1 over R total. Where should I put it? From here we have 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3. That is what is remaining here. So when I use 1 and multiply by this 1 remaining here, I have 1 over 1 over R1 and this other 1 over R2 over R3. Now this is the total resistance in this particular circuit. And that is the formula for when resistance is arranged in parallel. But there is a trick that most students normally use in calculating resistors in parallel so that it's going to ease their time and also make them to get the accurate answer as soon as possible. So when resistance is arranged in parallel, you may choose to use this formula, you may not use this formula, but on one condition. If there are two resistors on your question, you are going to use the formula we are going to derive now. So now let's say there are two resistors. So the initial formula will now become 1 over R total equals to 1 over R1 plus 1 over R2. That is, we are assuming there are what? Two resistors in a circuit question you are given. So now, remember this is the R total, which is the total resistance. And this is 1 over R total. 1 over R total does not represent R total. The only R total is this particular R total here. So we need to make this R total the subject of the formula. And to help us make subject of formula, we need to find the LCM of these two. So working that out, the LCM of R1 and R2. Now remember that R1 and R2 are not the same value. So because of that, if I use R1 and divide by R1, I'll have 1. But R1 cannot divide R2. I'll bring down with R2. Now R2 now is going to go to divide R2 give us 1. And this is the LCM values. So now R1 multiplied by R2 is going to give me what? R1, R2. That is the LCM. Now this LCM, we will use it to replace this denominator so that 1 over R total is now equals to all over R1, R2, which is the total what? The LCM I'm going to say. Now this 1 over R1 and R2 multiplied by 1 over R1. R1 will cancel R1 here. R1, R2. This multiply this will cancel this, giving us what? R2 plus R1, R2 multiplied by this expression here. This will cancel this, giving us R1 multiplied by 1, give us plus what? R1. Now here we are still looking for what? R total. Now in this case, this bracket will close and multiply. So this multiplied by this, I'm going to have R total bracket R2 plus R plus R1 equals to R1 R2. Remember we're looking for what? R total. So I'm going to divide both sides by R2 plus R1. R2 plus R1. Now, when this cancel this, you find out that the total resistance is also equals to, when you use the resistance and multiply each other and divide by the resistance added to what? Each one other. Provided that there are only two particular resistance here. Now, why did I say so? If there are three, the formula you're going to drive here is going to be as long as. So we have to leave it to be in this what? Fractional form. So that is it for the formula we have. Now let's look at small question on resistance in parallel and in series. So this is the question we have to try on this particular video. And here they are the same non-values, but now values in the arrangement in series. All right, this is parallel and this is what? Serial arrangement. Let's first of all solve this. So when resistance is arranged in series and then you have the voltage, what is going to be the current? So we're looking for the current. And current, from the formula, we know that V is equals to IR, which makes I, which is the current, to be V over what? R. Now, solving this is resistor, this resistor, this resistor. I'm not just going to put 6 here and now say, okay, this is V is 12 all over 6. No. 6 is just the resistance here, and 3 is also the resistance. But the total resistance here, which is in series, I need to calculate it, and that is why the formula is very important. Now, when resistance is in series, the total resistance is going to be the sum of them, which is 6 plus 3. And 6 plus 3 is going to give us what? 9. So now, this I'm going to put it here as what? 9 equals to, what can divide this? 4 can divide this, sorry, 3 can divide this to give us 4. 3 can divide to give us 3. Now, when 3 divided by, when 4 is divided by 3, we're going to have 1.3. and this is going to be ampere. You get. So after having known that, we have to move over to what? This other circuit. Now in this particular circuit, you have that the resistance is in parallel, and there are different ways we can solve this particular question. Remember, the formula is 1 over R total. That is when you're looking for the total resistance is equals to 1 over R1 plus 1 over R2. I'm stopping at 1 over R2 because we have those two resistance. But here, I don't want to use this formula. What am I going to do? I'm going to use this other formula that I taught you guys, that the R total is equals to the multiplication of R1 and R2 over the addition of R1 and then R2. The last one we made. So if you use that one to get total resistance, you're going to get the same thing. So we have here 6 multiplied by 3 over 6 plus 3. All right. If this is equals to simplify by 3, I think that would be giving us 18 all over 6 plus this is going to give us 9. And this is furthermore equals to 18 over 9 is still 9 times to give us this. So it is all over 1. 2. So 2 is the answer for this expression, and that is the total resistance. Now remember, we are asked to find the current, not the total resistance. So we need the total resistance in order to impute it in the current formula, which is equals to V over R. Because we cannot just use one resistance and assume that this is the resistance in this circuit, because there are two. So we need to find the total resistance, which we have gotten as 2. Now this is equals to, what is the voltage? The voltage is 12 all over the resistance, which is now the total resistance calculated to be what? 2. So when you just divide, we're going to have the current to be what? 6 what? Ampere. And that is the answer to this. Now, thank you for watching. In another